Hello everyone. So in previous video we saw what is controller and its type. Though we are already aware that controller is a necessary part to make any physical thing an IoT device. But in this session again we will deep dive into the question why controllers, and we will see what all the things controllers do for us. After that, we will go through how to choose controllers, and then we will see some of the best practices so that your solutions and devices will be best and without flaw. So now let's first see why controllers. So, in IoT, controllers play a crucial role in managing and controlling devices. Here are some reasons why controllers are essential in IoT. First thing is manage devices. Controllers are used to manage and control the IoT devices and networks. They can perform functions such as turning device on and off, adjusting settings, and monitoring device status. So let's understand this. So first of all, I told you for an IoT device we need some network module. We also need some sensors. We also need some actuators. But we can't control each of them separately. And this all device don't have its own intelligence. So here controllers come into play. So controller only control these all devices. It only decide according to the written logic at what time the network module should be turned on or off. It only adjusts the settings of network module, or be it sensor, or be it the actuator, and also it monitors the devices status. For an example, sensor is sending some data, so we can write a logic in a controller in such a way that, for an example, if sensor stops sending the data, the other actuator, maybe alarm or something, ring. So this all functionalities are possible due to the controller. Other thing is collect data. So from the sensor data is coming. Sensor can sense the data. Again, in future we are gonna see detail about the sensors. Okay. So right now you can think about the sensor as a some device which can collect the physical world data like temperature, like humidity, okay, and can send it to us. That's it. So controllers can collect data from the devices. They are managing this data. This data can be used to monitor the performance of devices, detect problems, and optimize their operation. Okay, process data. Controllers can process the data they collect from the devices. This can include performing calculations, analysis, and making decisions based on the data. So, in near future, we will make a project named Smart Light. There what we will do, if there is no light, there is no light, the LED should turn on. So here we are gonna use the light sensor and the LED, but we will write our logic in controller, and controller will collect the data from the light sensor, and according to data it will make the decision to turn on the LED. Now let's move to the next point. Reduces the network traffic. Controllers can reduce the amount of data that need to be transmitted over the network. They can perform some processing locally, which reduces the amount of data that need to be sent to the cloud. So again, IoT devices, the first processing happens to the physical data is at controller level only. So again, we will see about this in future lectures, how it actually happens. Because from sensor we get the raw data. It is the controller which make it meaningful and send it to the cloud. Fifth and final point is improve security. Controllers can help improve the security of IoT network. They can be used to implement security measures such as authentication, encryption, and access control. Overall, controllers are essential in IoT because they enable the management and control of devices in IoT network, allowing for efficient operation and optimization of network. So I hope now it is clear why we should use controller or why we need controller and what all the things controller do for us. Now let's quickly move to the next session. What is how to choose controllers. So choosing the right controller for IoT application can be a challenging task, but no need to worry. In this course, we will see how to choose the controller by making the practical projects, and we will make many projects. So after this course, I don't think this question will bother you, that how to choose controllers. But there are some general steps you can follow. First thing is define the requirements. The first step in choosing a controller is to define the requirements of the application. This include factors such as power consumption, processing power, memory, and connectivity option. So in previous video I told you about microcontrollers as well as SoCs, single board computers, FPGA, PLCs. So according to the power consumption, processing power, memory and connectivity option, we will choose different kind of controllers. Let me put a scenario in front of you for better understanding. So you you have the application that requires very low power consumption, and also you don't require heavy processing power. So processing power requirement is also low. Sorry, like due to lack of space I can't write full spellings. So processing power is also low. So in this kind of condition, can you tell me which kind of controller you can use? You can think about it. If you want, you can go to the previous lecture and revise it. Okay, I hope you are with your answer. So answer is microcontroller unit, because you need low power consumption and processing power is also low. So in this scenario, the microcontrollers fit the best. So now let's see the second thing. Evaluate the options. Once you have defined the requirements, you can start evaluating different controller options that meet those requirements. Research online and consider factors such as cost, availability, and the quality of the support and documentation. So, for an example, if you decide microcontroller, again I will take the same example. We need some controller with low power consumption and low processing power. So again you decide the microcontroller. So in microcontroller only there are many options. There are Arduino Uno, Arduino Nano, ESP32, ESP8266. There are plenty of big controllers, plenty of ARM microcontrollers, Intel microcontrollers, 8051, 8086. There are plenty. How will you decide? Again, you will see the cost. You will see in microcontroller only processing power differs. Like ESP32 have more processing power than Arduino Uno. So you will again decide using different factors like cost, availability, and support and documentation. So some of the controllers do have poor documentation and poor support. So you need to consider all these factors while deciding the controllers for your project. Let's see the third point. Consider a programming environment. Programming environment. It is essential to consider the programming environment when choosing a controller. Some controllers have simpler programming environment that may be easier for beginners to learn, while others may require more advanced skills. So again we will see what is the programming environment and how to program your controllers. So I won't explain you this point in detail because details will come in near future. Evaluate the development tool kit, or let's say development tools. So look for a development tool that are available for controller. These tools can make it easier to develop and test the software that runs on the controller. Consider scalability. If your application is likely to grow and acquire more processing power or memory, consider choosing a controller that can scale with your need. This can help avoid having to replace the controller in future. So this point is very important. So whenever you make your project, you need to also think about the scalability. How my project will grow in future, how the data processing will grow in future, and accordingly you need to choose the controller. Sixth point is look at the community. Finally, look at the community around the controller. The large the larger the community, the more resources, support, and example will be available online. So this point is also important. So indeed, if community is big and strong, you will get more resources. One of the reason Arduino is so popular is due to its community. Arduino have really big and rich community. By following these steps, you can choose a controller that meets your requirements and can help you develop your IoT application effectively. So now let's see some of the best practices. So first point is security. Implement strong security measures to protect the controller from cyber threats. This includes measures such as encryption, access control, and authentication. Second point is scalability. Design the controller to be scalable to accommodate future growth in the IoT network. This can include designing the controller to support additional devices in future. Interoperability are widely adopted in industry. Reliability. Design the controller to be reliable and available at all times. This can include using redundant hardware and software components to ensure that the controller can continue to operate even if components fail. Performance. Optimize the performance of controller by using efficient algorithms and code. This can help reduce the processing time and power consumption of the controller. Testing. Test the controller thoroughly to ensure that it meets the requirements of IoT application. This can include testing the controller in different scenarios and environments. Final point is documentation. Document the design, development, deployment of controller to ensure that it can be maintained and updated over time. This can include creating user manuals, technical specifications, and other documentation. So by following these best practices, you can develop and deploy IoT controllers that are secure, scalable, interoperable, reliable, performant, and well documented. So that's it for today's video. See you in the next video. Till then, bye.